Hi y'all, in this video we're going to talk about section 5.2 from your textbook, the definite integral, and you're definitely going to want your calculator for this, so if you don't have your CAS, stop the video and go grab it so that you can use your calculator while you're working through these notes. So the first thing we're going to do is we're going to review sigma, or sum notation. So hopefully you remember this from Algebra 2 Trig. If you see something like in example 1 with the sigma symbol, the number in the bottom is the first number, and the number at the top is your ending number. And so what sigma wants you to do is it wants you to plug in all the numbers from 1 to 5 into the function and add them together, because sigma means sum. So I'm going to replace n with 1, and then I'm going to replace n with 2, and with 3, and with 4, and with 5. So in this case, it's just a simple 1 plus 2 plus 3 plus 4 plus 5. But you can also do this on the calculator. So if you go to your graphing calculator and go to the calculator screen, if you go to Menu, Calculus, sums are right there, number 5. So if you pull it up, you'll see the sigma symbol. You can type it in exactly like it looks. You can actually use n. You don't have to change it to x like you do in the graphing screen. And so this summation equals 15. So I want you to pause the video and do this next two summations using your calculator. When you're done, unpause the video and the answers will appear. Okay, so the answer to 2 is 22, and the answer to 3 is 50. Okay, so the reason we're reviewing sums is because you can use summations to write the formula for left and right-hand sum. So if you remember, left-hand sums start at t0 and go up to tn minus 1, whereas right-hand sums start at t1 and go all the way to tn, and everything gets multiplied by delta t. So we can actually make this a summation formula because we're adding things. Notice everything gets multiplied by delta t, so we can pull that out front. So we're going to make a summation symbol. So for a left-hand sum, our value starts at 0, and we're going to use I to represent the subscript. So this would be I. We're just going to call that I. So I starts at 0, and it goes all the way to n minus 1 for a left-hand sum. And so inside, we would have the function value at every t sub I. Again, I just represents the subscript number. And for a right-hand sum, again, we can pull the delta t out to the front because everything gets multiplied by delta t. And a right-hand sum, instead of starting at 0, it starts at 1, and it goes all the way to n. And a function value, again, t sub I. So it just makes writing the formula shorter, so sometimes you'll see it in a summation, so don't let that freak you out. Summations just mean the same thing, add things up. So let's try this practice. Write the left and right-hand sums of f of x equals 2x squared on negative 2 to 3 with n equals 5 in sum notation. Find each of these sums. So whenever you're doing a left and right-hand sum, you got to solve for delta t. If you remember, delta t is b minus a over n, where a and b are the endpoints. So in this case, delta t is just going to be 1. So it's not much of a factor there. So for our left-hand sum, we would set this up. So we're going to start at the a value. So we can say x equals negative 2. Then we listed out all the values between negative 2 and 3. So we'd have negative 2, negative 1, 0, 1, 2, 3. For a left-hand sum, we want to start at the beginning and go to the second to last one. So we're going to stop at 2. So on top of our sigma, we're going to stop at 2. And so inside the sigma, we're just going to put the function. So in this case, it's 2x squared. Now, technically, we should be multiplying this by delta t out front, but delta t is just 1. And so you could type that in your calculator. And if you type that in your calculator, you should get a value of 20. A right-hand sum is going to be almost identical. You're multiplying by delta t, you're setting up your summation, except for a right-hand sum, you start with the second term and go all the way to the last term. So now we would start at negative 1 and go all the way to positive 3 and put 2x squared. And again, if you type that in your calculator, you should get 30. So left and right-hand sums can be written with summation notation. Okay, so how does this relate to the definite integral? So suppose we have a continuous function. It's got to be continuous, so it has a derivative on some interval a to b. The definite integral represents the area under the curve, okay? And so the symbol for the definite integral is this big curly S. It's been like flattened out, this flattened out S. You can think of the S for sum. It's an old-fashioned S for sum. And you can think of the curve as replacing the sigma. So normally this would have been a sigma. You would have had the function. And the dx is like the delta x, okay? So A is the beginning point, B is the end point. So just like in a summation, you write them on above and below the sigma. This time you're writing them above and below the integral symbol. F of x is the function, and now we're calling it dx instead of delta x, but same idea. So what is a definite integral, really? What is the definition of a definite integral? So the definite integral is the limit of the left or right-hand sum within subdivisions of a to b as n goes to infinity. Oh, goes to infinity. So I know that sounds very confusing, but if you think about it in general terms, so if you remember, a left and right-hand sum estimates the area under the curve of some graph. And so if I wanted 4 subintervals, I would make 4 rectangles. So if n is going to infinity, I'm going to get more and more and more rectangles. So the idea of n going to infinity means I'm going to get an infinite number of rectangles. And so if I use an infinite number of rectangles, eventually I'm going to use every bit of this area. There's not going to be any gaps between the rectangles and the curve. So by taking the limit to infinity, I'm finding the actual area under the curve, not just an approximation like the left and right-hand sum. So all we do to make an integral is stick the limit as n goes to infinity in front of a left or right-hand sum. And when you do that, they're going to actually be equal to each other. So whether you use the left or the right, when you take the limit to infinity, they become the same value. So we would think of the sum as it's called the Riemann sum. Riemann was a mathematician, and he's the one that invented them, so we named them after him. The function is also known as the integrand, and we call a and b the limits of integration, and they can also be called the constants of integration. So that's just a little bit of vocabulary. Don't let this complicated formula freak you out. We're not really going to do much with the whole limit to infinity thing, but it's just the idea of an integral equaling the limit to infinity of a summation. So we want n to go into infinity so we get that perfect area covered and we have no missing gaps. Okay, so we want to find the area under the curve x squared plus y squared equals 1 from -1 to 1. So if you remember, x squared plus y squared is actually going to be, that's the equation of a circle. And if we just take it from -1 to +1, it's just going to be a semicircle. So we're trying to find the area under the semicircle. Well, luckily for us, there's already a geometric formula for that. If you remember, the area of a circle is pi r squared, so the area of a half a circle is 1/2 pi r squared. This circle has a radius of 1, so this area would just be a half pi. But now we can actually do this using calculus instead of just using instead of using area formulas from geometry. So in calculus, we use an integral symbol to represent area. So we would say we want to take the integral, we're starting at -1 and we're ending at +1. Now we need to put the equation after the integral symbol, but it has to be a y equals equation. So if we go back to our equation, we need to solve this for 1. And so that would be 1 minus x squared, and since it's the positive square root, the positive part of the circle is going to be the positive square root. So we're going to put the square root of 1 minus x squared, and then all you need to do is just tack a dx on the end to represent the delta x. You don't actually do anything with that. And so you're going to go to the calculator. If you go to Menu, Calculus, if you see number 3, it says Integral, and it's going to pop it right up in your screen, and you're going to fill it in exactly like what's on your paper. Again, you can use any variable you want. It doesn't have to be x. In this case, we're using x. And so you come over to the d, and this is dx, so I'm going to put an x there. And so the area is pi over 2, which is exactly what the area formula told us. So when you want to find area under a curve, from now on in calculus, you're going to set up an integral. So right now, I want you to try example 2 and example 3. Set up the integral, type them in your calculator, get the answer. So pause the video, see if you can get the answer, and then I will put the answers up for you to check. Okay, here are the answers. If you got one wrong, ask your teacher when you come to class. Okay, in example 4, we want to use the figure to estimate the area under the curve. Integral means area. So if we're trying to estimate area under a curve, the only tool we can use on the graph is left or right-hand sums. So the first thing you need to do is identify some y points, some y values on this graph, and it makes it really easy if you just do them every one whole number. So if I'm going to do a left-hand sum, I'm going to start at the leftmost endpoint and make a rectangle. And then I'm going to start at the next left point, make a rectangle, and one more. So I'm going to get 3 rectangles out of that. So my left-hand sum, so that first rectangle is 16 times 1, second rectangle is 8 times 1, and the third rectangle is 4 times 1. So my left sum adds up to 28. Now if I wanted to do a right-hand sum, I'm going to start at the rightmost endpoint and make rectangles. So the first one doesn't change. The second one's going to start here, though, so the second right-hand sum is a little bit smaller, and the third one's going to be here. So for my right-hand sum, I'm going to have a rectangle that's 8 times 1, and then a rectangle that's 4 times 1, and another rectangle that's 4 times 1. So my right-hand sum would be 16. And so the only way I can estimate the area here is to find left and right-hand sums. Now, I could also average these together, and that would also give me an estimate of the area. So all of these estimates are appropriate. Whether you say 28 or 16 or 22, all of those answers are correct. Okay, so here's a graph, and they're telling us that the area of A is 3. However, because this area is below the x-axis, we need to really consider that as an area of -3 when we're talking about integrals. Area in general is always positive, but integrals can be negative. It just means that the area is under the x-axis. So B is going to be -2 and C is going to be 5. So if I want to find the area from 0 to 5, 0's here, 5 is here, I'm taking the area of A plus B. So in this case, A is going to be -3 and B is going to be -2. So the integral from 0 to 5 is going to be -5. So you try B and C, pause the video. When you're done, when you think you have the answers, unpause the video and I will put the answers up for you. Okay, so for B you should have gotten 3 and for C you should have gotten 0. All right, in this last example, we're going to do a very similar idea. We want to use the picture to find integrals, and again, you got to think integral means area. So for the first integral, we want to go from -2 to 0. So we're finding the area under the curve. So it's the area between the curve and the x-axis. That's a nice triangle shape. If you think triangle is a half base times height, this triangle has a base of 2 and a height of 2. 2 times 2 is 4. So half of that is 2. So this triangle has an area of 2. So my integral also equals 2. For part B, I want to go from 0 to 2. So I'm going to take the area from 0 to 2. Again, the area is the area under the curve and between the x-axis. This is also a triangle with a base and a height of 2, so it also has an area of 2. So you try the next 5. Pause the video when you think you've got them all. Unpause the video and the answer will appear. Okay, so if you have any questions on those, bring your questions to class and we'll discuss them.